So let's draw a small GSM network, and then we'll illustrate. We'll go through each one by one, and then so very quickly we're going to draw this simple network, GSM network. This is BTS. We will have EIR, equipment identity register, and here is VLR. It's a simple GSM 2G network, and we'll go one by one. This is a mobile equipment. It has something called as subscriber identity module, which is called a SIM. So let's go one by one and describe the architecture, or describe the network elements in the architecture. So let's go with mobile equipment. Now, what are the functions of a mobile equipment? We'll look into the functions, or what mobile equipment has, or what it does. We'll look into it in a second. It's responsible for voice encoding and transmission. Voice encoding and transmission. Okay. And then it's responsible for frequency and time synchronization of the channels. So frequency and time synchronization of the channels. So that means it mobile equipment, the mobile, which we call the cell phone, is responsible for attuning to the right frequency and syncing itself with the right time slot. It's also responsible for voice encryption, decryption, decryption. Okay, let's go. It is also responsible for measuring the power from adjacent cells. This function is responsible for handoff. So if the mobile feels that there's a greater power from an adjacent cell, it's gonna request a handoff. Okay, mobile equipment. It stores IMEI, which is a short form of International Mobile Equipment Identifier, which is inscribed in the mobile equipment by the manufacturer for security reasons. So we just saw, what are the functions of a mobile equipment, which we call as a cell phone. Now let's look at the small SIM that it has. What is the function of a small SIM that it has, right? Let's look at that real quick. Number 2, subscriber identity module. Let's go with the same color. Okay, this is a portable smart card with a little memory. Portable smart card with a little memory. This is 2.1. This is 2.2. It stores some permanent data. One of the permanent data it stores is IMSI, International Mobile Subscriber Identity, for that particular mobile handset and subscriber. This is the subscriber information to make a voice call, and it also stores PIMSI for a packet or data call. It stores the authentication parameter called the KI, which is 128-bit. This is required to be stored in the mobile equipment for for authorizing authentication of mobile by the network. It stores the authentication algorithm A3 and the ciphering algorithm A8. It also stores the encryption key, which is the KC. Some of the temporary data that it stores is TMSI, temporary mobile subscriber identity, LAI, location area identity, or RAI, routing area identification for packet. This is for packet. Okay, so we just saw what a SIM stores. So let's move on to the BTS. Do we have space is what I'm concerned about. Let's make some space here. This is called the base transceiver system or station. It's called the base transceiver station, which is right here. We're going to talking about right now, in case you're wondering. Wrong color. This handles the radio interface. The radio interface. It receives data transcoding. Data transcoding. It is responsible for voice encryption, decryption. As we saw, the mobile is responsible for voice. Mobile equipment is responsible for voice encryption, decryption as well. So when the voice is encrypted, decrypted here, it has to have a counterpart here for it to be, decrypted back to its normal, where it's processed again. It's responsible for uplink radio channel power measurement. Uplink radio channel power measurement. All right, awesome. Now let's look at the BSC, which is right here, and how are we gonna do that? I think we can use this space efficiently. Efficient utilization of space. BS, base station controller, is what BSC is called. It provides all control functions and physical links between the MSC and the BTS. So control functions plus physical link between the BTS and the MSC and vice versa. This is responsible for monitoring and controlling the BTS. Monitor plus CTRL BTS. It is also responsible for management of channels on the radio interface. Manage radio channels. So what that means is it in cases of handovers, in cases of channel assignment to the mobile equipment, this is the decision, the control, the intelligence is in the BSC, where it tells the BTS to assign radio traffic or radio channel to the mobile. That's why it's called, that's why this is the brain of a BSS, base substation system. This is what when I say BSS, this is what I'm talking about. BSS is these two entities together is called the BSS. So this BSC is a control function of, basically it controls the BTS and also radio resources. It's responsible for switching from the A bis interface, which is here, to the A interface here. So switching from A bis to A interface, right? Awesome. Now we're gonna look at the MSC, Mobile Switching Center, and for that we need some space. So I'm actually rubbing the functions of ME just in case you have not noted it down. You can go back to the video and see it for yourself. Okay, we're good to go. So let's look at MSC, Mobile Switching Center. So switching means it's responsible for switching the calls from one PLMN to PSTN and PSTN to PLMN. So that's one function. The second function is handover function. Handover means that's an inter-BSC handover. Handover means mobile moves from one location to the other location and wants to attach itself to another BSC. MSC is the one who takes the decision of handing over and allocating radio resources from the new BSC and deallocating resources from this current BSC. The third function is it is an interface to the PSTN network, like we already talked about, and then it's responsible for paging for incoming call to the mobile, and it's also responsible for billing. So basically, this is the heart of the NSS, network switching subsystem, which is this. You can call this whole thing as NSS. And this guy BTS and BSC is called the base station subsystem. So let's now look at the home location register, which is this guy out here. Right, so let's see. Home location register. This guy stores the subscriber information. Any subscriber which subscribes to a GSM service, his or her information has to be stored somewhere. So this is the guy who does that. Let's see what it stores. The international mobile subscriber identity is the first piece of information it stores. The second is the MSISDN number, which is the cellular number of the subscriber, is stored in the HLR. HLR is the home location register of the mobile. When the person first for the first time buys a cell phone or a mobile, it switches on the cell phone or mobile, and that's when all the subscriber data, all that is stored in the HLR, and that's why it's called the home location register. That means that HLR is the home of all the subscriber information which is registered in that area, in that geographical area, in that location. It also stores the VLR address. We'll talk about what VLR is. VLR is Visitor Location Register. We'll talk about it a little later. It stores all the subscription information. So all the services that the mobile has, what kind of subscription it has. Does it have text messaging, SMS, internet, whatever. It also stores the reference to authentication center for getting the key KI, which is the authorization key. And HLR is referred to, or it's called upon when a call comes from public to the public landline to the cellular network, to the mobile network. That's when the MSC calls the HLR for information. So this is a little bit about this guy HLR.